topic called harmonics. Now, if you still recall, we say what is a DC voltage? If it's a DC voltage, means it's constant all the time. Alright, if I say here is 6 volt, that means it's always 6 volt. So this is a DC value. Whereas if it's a sine wave AC value, AC voltage, right, it is actually changing in a sine wave format, right? This is the voltage and this is the time. And here, let's say it's 12 volt, then peak voltage is 12 volt, the negative peak is minus 12 volt, peak to peak is 24 volt. Can you recall this? And then VRMS is equal to Vp divided by square root 2. So in this case, it is 12 divided by square root 2 volts. Right, so this is called the DC, and this is called the sinusoidal or AC signal, right? And this is the peak, this is the negative peak, and the peak to peak is 24. VRMS is Vp divided by square root 2. Okay. Now then we say that, let's say if I say this is 50 Hertz, the frequency is 50 Hertz. Alright? And if I have a multiple of it, another sine wave I have, and the frequency is equal to 150 Hertz. Okay? Then I say that this is the third harmonic, because this is the fundamental, the first first harmonic. Second harmonic will be 100 Hertz. Third harmonic will be 150 Hertz. So you just keep on multiplying to get this number of harmonics. Right? So that's the introduction. Okay, so now let's come back to look at this voltage signal here. Now here I have this 10 volt. So this is your DC value, DC voltage. Okay, or we call it the average voltage value. Alright? And this is a sine wave. This is also a sine wave. This is also a sine wave. So harmonics is basically referring to our pure sine wave. This is a pure sine wave. Okay, this is ideal. That's what we want, a pure AC. But sometimes, due to some noises and unwanted harmonics, we will have a sine wave like this. Right? It is still a sine wave, but it's not so pure. It's not so pure, and it is because of harmonics. Harmonics basically means you have multiple frequencies that appears in the signals, and it can actually be proven that is actually an addition of different harmonics. Right? In this case here, this is my fundamental. 100 pi t is my fundamental, and this 300 pi is times 3, so it's the third harmonic, and this is the fifth harmonic. Now you still remember that this is 2 pi ft, right? 2 pi ft. So if I were to ask you to find me the fundamental frequency, you can say 2 pi f is equal to 100 pi. So therefore, what is f? Alright? So 2 pi f is equal to 100 pi. So f is equal to 100 pi divided by 2 pi. So that's equal to 50 Hertz. So my fundamental frequency is 50 Hertz. Then my third harmonic is 150 Hertz. And my fifth harmonic is 250 Hertz. Okay? So this is the meaning of this string of values here. Alright, now we need to understand how to find the VRMS of this voltage signal here. Alright, or we call it V effective voltage, or the RMS voltage. Now the formula is actually square root of VDC squared plus V1 squared plus V3 squared plus V5 squared. In this case here, every one of them. Now basically all these are the RMS value. So it's therefore equal to 10 squared plus 141 divided by square root 2 squared plus 42.3 divided by square root 2 squared. Okay, and I do not have, I have V5, so it's plus 28.8 divided by square root 2 squared. So in the voltage signal, that consists of a series of a DC value as well as the harmonics of different frequency. And when we are asked to find the root mean square or the effective value, make use of this formula, and that's the way you do. Always remember this means RMS. Okay? So if I have another current signal, so this is a VRMS now, so we have found it already. So now the IRMS, so if I have the current waveform, which is equal to 5 plus 16.5 sine 100 pi t plus 54.5 degree plus 8.43 sine 300 pi t minus 38 degree plus 4.65 sine 500 pi t minus 34.3 ampere. Okay, so this is the current. In other words, I'm having an AC system. And this is my voltage. And this is my current. Right? Okay, we are able to calculate the VRMS already. Right? We know how to do it. Right? Which is equal to 10 square plus 141 divided by square root 2 square plus 42.3 divided by square root 2 square plus 28.8 divided by square root 2 square. Okay, so we got the value. How about the IRMS? Same. It's the same method. Square root the square of this DC value plus RMS square plus RMS square plus RMS square. So it will be 5 square plus 16.5 square root 2 square plus 8.43 divided by square root 2 square plus 4.63 divided by square root 2 square. So with that we get the VRMS and IRMS. Alright? Now the next one is to find the power. Okay, the total power in this circuit here. Right? And what we do is that we use VI cosine theta formula. Of course, this is the VDC times IDC. The first one, but there's no cosine theta because it's true value, DC value. But the second one, you then have to have V1, I1 cosine theta, V2, I2 cosine theta, and V3, I3 cosine theta. Sorry, I should say 3 because it's the third harmonic, right? And the fifth harmonic. Okay, now, so it's 10 times 5. 10 times 5, powers could be times I, so it's 10 times 5. That's the first one. Second one, remember power formula must be all RMS. So V1 is 141 divided by square root 2. Okay, and multiply the I will be 16.5 divided by square root 2. So this is VI. Cosine theta. Cosine theta is about the theta between this and this. So the theta here is 0 degree, the theta here is 54.5. Right? So 0 minus 54.5 is minus 54.5 degree. So it's cosine minus 54.5 degree. Or you just want to think what's the angle between 0 and 54.5 is 54.5. Right? It's the same in terms of mathematics. Then the next one, 42.3 square root 2 divided by square root 2 multiply 8.43 divided by square root 2 cosine what? This is 0 degree, it's minus 38 degree. So the angle is 38 degree. 0 minus minus 38 is 38. So it's 42.3 multiply 8.43 and it's cosine minus 38 degree. Okay? Third one will be the fifth harmonics. 28.8 divided by square root 2 multiply 4.63 square root 2 cosine, what's the angle? 0 degree and minus 34.3 is 34.3. Okay, so remember the method to find the total power. VI cosine theta, VDC IDC, V1 I1 cosine theta, V3 I3 cosine theta, V5 I5 cosine theta. Make sure that power is all RMS value. Okay, alright, then the lastly is to find the power factor. Now, power factor is equal to cosine theta, right? Cosine theta. And if you have this right angle triangle, this B, this Q, this S, what is cosine theta? Cosine theta is equal to B divided by S, right? B divided by S, correct? Now, just now, we have already calculated P. That's your P, right? The total power, right? So we know the P. Then what is S? S is equal to V times I. Remember, S is equal to V times I, and both must be in RMS. So this P is the value that I calculated just now. Okay, and S must be my V RMS multiply my I RMS. Have I calculated them just now? Yes. Right? Remember, V RMS, I RMS. Okay? Right, so this is the first part of the harmonics. Alright, so let me repeat what I've just said. If I have an AC system where I give you my AC voltage and my AC current in a sinusoidal expression, can you use these methods to find the VRMS? Same method to find IRMS. Once I know both, can I find the power? Yes. VDC, IDC, V1, I1 cosine theta, V3, I3 cosine theta, V5, I5 cosine theta. What are the value of this V and I? RMS. Then, how do I find power factor of my AC system there? Power factor is cosine theta is equal to P divided by S. Have I calculated P? Yes. The VI cosine theta, a string of them. And my S is V, total V, total multiply total I. Both must be in RMS. Okay? Alright, so based on the same thing, now let's go through one more examples. This time, I don't tell you the I. Maybe I should cut first.